Intermediate Algebra, Section 9.3, Graphs of Logarithmic Functions. They're asking us here in this example to graph the log base 2 of x is equal to y. We're going to translate this logarithmic function into its equivalent exponential form, which would be base 2 to the y power is equal to x. We can find ordered pairs that are solution by choosing values for y then and computing the values of x. So our x, or in this case, will be 2 to the y power. Again, we'll start with a y value. To simplify, so we have 2 to the 0, which is equal to 1. We put a 1 in, 2 to the first is 2. Let y equal 2, we have 2 to the second is equal to 4. It's going to ever increase as our y values increase. Let's try some negative values. 2 to the negative 1 would put that exponent in the denominator to make it positive, so it'd be 1 over 2 to the first power, or 1/2. If we let y equal negative 2, we would have 2 to the negative 2 power, which is 1 over 2 squared, or 1/4. We have enough points. Let's plot those points. And even though we started with y, our ordered pairs are always x, y. So we'll plot the point 1, 0, 1, 0. We'll plot the point 2, 1. We'll plot the point 4, 2. So over 4 and up 2. We're going to plot the point 1/2, negative 1. So halfway and negative 1. We had 1/4 when we simplified here is negative 2, so 1/4 is negative 2. And if we connect those points with a smooth curve, we've seen something very similar to this earlier. This is the function that we're asked to graph, but using the definition of a logarithm or a logarithmic function, they are the inverse of the exponential function. So just for reference sake, if I graph the y equals x line and I reflect these points about that line, this point 2, 1 becomes 1, 2 when we reflect it through there. The point 4, 2 becomes 2, 4. This point here, which is 1, 0, becomes 0, 1. Our half negative 1 becomes negative 1, 1/2, and so on. And if we do a smooth curve here, we end up with the reflection or the inverse of this logarithmic function. And if we investigated this further, we would end up finding that the inverse of this logarithmic function is actually 2 to the x is equal to y. And this is here solely for reference of showing that the exponential functions, a base raised to a power, has an inverse of the logarithmic function.